The TI-84 makes it so easy to find a confidence interval for a difference of two means. We're going to dive in with this example and find the 95% confidence interval for the difference in screen time between our college students and our high school students. Now here's our data. We want to label these to get them into the calculator. We want to label them as a sample 1, we'll let that be the high school, and a sample 2. The calculator is also going to ask for each of these values, but by using the symbols. So we're going to change the number of students into an N1 and an N2. We're going to change those means, again to match the TI-84, to an X bar 1 and an X bar 2. And those standard deviations to an S1 and an S2. Now we know what the difference of our sample is. That difference happens to be 45, but we know that for the population, it's not going to be 45, but it's going to be maybe somewhere around there. We call 45 our point estimate, but we're going to make this interval, actually the calculator is going to construct this interval for the difference of the population means mu1, all of the high schoolers, minus mu2, all of those college students. Now this confidence interval looks like this. So I've got the difference, the actual difference in the middle, and we're going to bump that 45 out using a margin of error, or the calculator is. So that lower value that we're going to find with the calculator is 45, our estimate, minus a margin of error, and that upper value is going to be 45 plus a margin of error. Let's go ahead and get our values into the calculator. To find that confidence interval, we're going to go to the stat menu, so stat, and then arrow over using your right arrow over to choose tests, and we're looking for an interval. Now we were only given a sample standard deviation for the high schoolers and the college students, so that means that we automatically need to use a T interval instead of a Z interval. We would need the population standard deviations to use that Z. So as I'm scrolling down, I'm looking for 2 sample T interval. So scrolling down, there's the 2 sample Z interval, but we've got sample standard deviations. There's what we want, that 2 sample T interval. As soon as I've got that selected, I can hit enter. Now it gives you 2 options here for that first input line. The first one is data, which we're not going to be using, but your calculator might look like this. Well, we don't have raw data. We don't have a bunch of student screen times to average. Instead, we've got our summary statistics. So if it wasn't already, I'm going to right arrow over to stats and then hit enter to select that. Now take a look at all those symbols. They match the symbols that we put in our table. So let's put these values in really carefully. Okay, so X bar 1, that's going to be our first sample's average. The standard deviation for that first sample is 23, and I've got 20 for N1. X bar 2, that's 315. That second sample standard deviation is 15, and we had 18 in that sample. We did want a 95% confidence interval, but this is where you could type right over. Say you wanted a 90% confidence interval or something, but I don't. So I'm going to just put in a 0.95, typing right over that. Continuing to arrow down, we're going to be choosing pooled no. If you happen to be in a more advanced statistics course and you know that your variances are equal, you would use yes, but for AP stats, for intro to stats, we're going to leave that pooled as no. Arrowing down one more time, I'm ready to calculate. This is where the magic happens. And there's my confidence interval. Now it's given to me as the lower number, comma, the upper number, but we really need to put these numbers into that interval form. Let's go ahead and round that first number to be 32.3, and we're gonna round that second number to be 57.7. Now this 95% confidence interval tells us that if we resample high school and college students over and over, 95% of those differences will lie between 32.3 and 57.7. I've got another video for you here.